Welcome to this Maths Made Easy video on probability and Venn diagrams. To start with, let's take a look at calculating probabilities. So, to calculate the probability of an event, the following formula is required. So the probability here is given by the number of desired outcomes, so that's the number of desired outcomes what we do here is we divide this by the total number of possible outcomes. So this is the total number of possible outcomes. Okay, and that would give us our formula there for the probability. Now, for example, what is the probability of obtaining an even number when rolling a fair six-sided die? So the possible outcomes here are 1, 2, 3, 4, 5 and 6. But the only even numbers there are 2, 4 and 6. So the possible outcomes, if we just note this here, are 1, 2, 3, 4, 5 and 6. However, the even numbers that we require here, the probability of an even number, well, that means we need to get either a 2, a 4 or a 6, which means there's 3 desired outcomes out of 6 possible outcomes. So in that case, the probability of rolling an even number, is equal to 3 out of 6, which simplifies to a half, 1 over 2 there. So that gives us everything we need there for calculating probabilities. Moving on now, take a look at and or. So if we see the following notation here, so something that looks like this. So let's say we've got A, and this funny looking N with say B here. Well, this means A and B. We read this as A intersection B, but that's A and B. Okay, so A and B. And that tells us that both event A and event B happen. And if we see the following notation here, so A with a little u here in the middle, B, this is A union B, which we read as A or B. Okay, and that tells us that event A happens, or event B happens, or both happen. Now the probabilities of A intersection B and A union B are related by the following formula. So the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Okay. Now these probabilities can be calculated with a Venn diagram. So for example, if we take a look at this Venn diagram here and consider dice again, if A is rows which are a multiple of 3 and B is rows 3 or 4, then we have the following Venn diagram. Now by looking at where the circles overlap, we notice there is one value that intersects here, which is this 3. So A intersection B contains one value. And by looking at the circles in their entirety, we notice that there are 3 values contained within circle A or circle B. So A union B contains 3 values. Since there are 6 values overall, we can conclude then that the probability of A intersection B is equal to 1 out of 6, and the probability of A union B is equal to 3 out of 6, which simplifies to give us a half there. Okay, so that gives us everything we need there for and or. Moving on now, take a look at the complement of an event. Now the complement of an event is the event that it doesn't happen. For example, if A is rows 3 or 4, then the complement of A, written A with a little dash here, which is this notation here, well, that is not a row of 3 or 4, i.e. rows 1, 2, 5 or 6. Now, since any event definitely either does or does not happen, the probability of an event and its complement must sum to 1. So therefore, we can write this then as the probability of A plus the probability of A complement is equal to 1. Okay, so that's equal to 1. And on a Venn diagram, the complement of A is everything not contained within the circle representing A. Okay, and we can see that in this example here. So A is represented by this green circle, and A complement is everything not contained within the circle here representing A. So that gives us everything we need there for the complement of an event. And finally, moving on now to two-way tables. So two-way tables model two events, say A and B, by displaying every combination of whether or not each one happens. They can either display frequency, which you should be familiar with from GCSE, or probability. If it does display probability, then the numbers in it, excluding row totals and column totals, must add to 1. And the final total in the bottom right must be equal to 1. And we can see an example of that here. Okay, notice the bottom right here is equal to 1. Now, we can also note here the totals are probabilities for one event. So for example, the total in the A column is the probability of event A, and using this we can create the most general form of a two-way table. So here, the probability of A and B happening, well, that would be the probability of A intersection B, the probability that they both occur. If we wanted to say the probability of B and A complement, then that would be the probability of A complement intersection B there. Okay? And the total here, if we just think about what the total would be, like you've got the probability of A intersection B and the probability of A complement intersection B, well, that would just simply give us the probability of B here. Okay? So if we've got B complement and A, then we could write that as the probability of A intersection B complement. And if we've got B complement and A complement, then we could write that as the probability of A complement intersection B complement. And again, the total here, well, in this case, this would simply be the probability of B complement. And if we think about our column totals here, well, this would simply be the probability of A, and this would simply be the probability of A complement. Okay? So that gives us everything we need there for two-way tables, and that concludes this maths media video on probability and Venn diagrams.